Hello to you and welcome to my channel and to this theoretical introduction to temperature measurements with thermocouples. So there are many applications where you will need to measure temperatures. In my case, I wanted to monitor the temperature of a thermostatic bath where I do sous vide cooking. So basically monitoring the temperature of water. And how can we measure temperature? This is the big question, the first question that we are making ourselves in this channel. Well, you have many different possible sensors that you can use and many different choices. Today we will use a very common, very cheap one, but there are also many other alternatives. So we will be using thermocouples. As I said, there are different also common sensor, like for example the thermistors. Thermistors are sensors where the temperature depends, the resistance depends on the temperature. We have also silicon band gap sensors, a little bit more complicated, but the principle is more or less similar. And then integrated components where the temperature is given in output in digital form. But we are talking about thermocouples. So the principle behind the thermocouple measurement is the Seebeck effect. We will not go into details on how this works, but basically when you take two different metal alloys and you get them in contact at some point, like for example alumel and chromel, that are commercial name, let's say, for these alloys, you will get what is called a junction. Okay, so when these two different metal touches themselves, they start to generate a voltage that is proportional to the temperature. So under an electronic point of view, we can say that we have a voltage generators whose voltage is proportional to temperature. And this is very cool because it's such a simple sensor, just two wires touching themselves. We have different type of thermocouples, and the difference is in the alloys that are used to make these thermocouples, and also the output is different for these different alloys. So you have these EJ/KM type thermocouple, each one with a different output, and what we have to notice here is the value of this output. So it's very small. We have just a few microvolt per degree centigrade. And this means that we have a very noisy signal, okay, and that we need to amplify this signal in order to get a value, okay. So let's think about a little bit the electronic that we will use, so the measurement circuit. And just an example here, when you connect the wires to our measurement circuit, you have another junction with two different metals, because the measurement circuit is generally made out of copper. So you have created two more thermocouples here. These are called cold junction. And in order to get the measurement value, we have to know the temperature of this junction called the reference temperature. So different thermocouples we say that can have different voltage output in terms of absolute value, let's say, but there is also another problem. If you change the thermocouple type, the curve can be very different. So the response, the generated voltage against temperature, can be also non-linear and can have different coefficients. Okay, so we have to pay attention also in that when we design our circuit. So why do we bother to use a thermocouple if it is quite so difficult to measure it? Well, the thermocouple is very, very cheap, since it is a sensor made by two wires, and you can also build a thermocouple yourself. It comes in standard formats and have standard connectors and can cover different ranges of measurement. The cons for the thermocouple is that we have a very poor resolution. Okay, realistically 1 to 2 degrees of resolution is a good idea, And to measure the thermocouple, the circuit can be very, very complex, very complicated, okay? What is the target of this series of the video tutorials on thermocouple measurement? I wanted to have a device where I can see the temperature of one thermocouple that I will insert in my thermostatic path, and I also wanted to be able to save the data that I'm seeing, okay, so save the data in an SD card in order to be able to see after I'm doing my cooking process, blah blah blah, how the temperature changed during the time, okay? So quite easy, and I will show you everything from start to end. So let's build it. Thank you for joining. And well, this is the first video of this channel. It is something that I wanted to do for a very long time. Is my way also to give back a little bit to the community of YouTube, where I learned so much from so many people. I will covering everything from theory to hardware design, software design, and so on. So keep in touch, stay connected, comment, like, and subscribe if you enjoy these videos, and see you soon.